All right, welcome to the review for Unit 7 on inequalities and absolute value. So we started with one variable inequalities. This one is x is greater than -3, 1, 2, -3, greater than, open circle because there's no or equal to, and the number is greater than -3 this way. X is less than or equal to 6, 1, 2, 3, 4, 5, 6. Close circle on 6 because or equal to, and the number is less than 6, so that way. We have a compound inequality in 3 and 4. The first one is the and variety. X is greater than -5, 1, 2, 3, 4, -5. Open circle. X is less than or equal to 4, 1, 2, 3, 4. Close circle. And the and variety typically is in between, right? These are the numbers that are both greater than -5 and less than or equal to 4. The next one is the other kind, the or inequality. X is less than -1, open circle, and the numbers that are less are this way. And x is greater than or equal to 4, 1, 2, 3, 4, close circle on 4. Make sure it gets closed and greater, right? Now, if this was the word and, this would be no solution. But it's the word or, and a number can be less than -1 or greater than or equal to 4. So we solve inequalities just like we solve equations. I like to get rid of the x's where there are fewer of them. So 7x minus x is 6x plus 8. You just keep that symbol just the way it is. This is a two-step. 6x is greater than, what is this? 54. Divide both sides by 6. X is greater than 9. Make sure you don't put an equal sign. Greater than 9. We could do other things, but I like to use distributive property anytime I see parentheses. And we're adding 8 to both sides. -6x is greater than or equal to 18. What important thing am I about to do? I'm going to divide both sides by a negative. So that means I'm flipping the symbols around, and the numbers that make that true are less than or equal to -3. Tank Spring Lake, and the water level started to drop from 20 meters at a rate of 6 meters every 3 hours. So it's going down 6 meters every 3 hours. It's going down 2 meters per hour. That's what's going on. So the rate here is -2 per hour. It starts up at 20 meters, right? And we want to write and solve and determine when it is below, it's less than, below, not or equal to, below 4. That's the inequality we're trying to solve. And so we just wrote it. It says right. Now we're going to solve it. So we're going to subtract 20 from both sides. -2h is less than -16. Notice they're both negative here. So when we divide both sides by -2, we flip the symbol. Right? How long is it going to take the water to drop below 4 meters? To get below 4 meters, it's going to take more than 8 hours. H is greater than 8. A number is greater than 7 and is less than or equal to 15, but it says single inequality. So what that means is we're looking for this. X is between 7 and 15, including 15. Solve and graph that. All right, so that's an and inequality. And when you have those, you can do it to all 3 sides, which I think is sort of neat. -5 minus 1 is -6. Less than 2x, less than or equal to 6. And then we divide all 3 sides by 2. -3 is less than x is less than or equal to +3. 1, 2, 3, -3, open circle, +3, closed circle. And we want the x's in between. A salesperson earned between $100 and $120 inclusive. So between $100 and $120. He was paid $40 for showing up and $4 per sale. So we're going to use X for the sale because we don't like to use S because it looks like a 5. And he got paid $20 just to show, $40 just to show up. That's the constant. So we just wrote a compound inequality, and now we're going to solve it, right? We're trying to get X by itself, so we're going to subtract 40 from all three sides. Divide all three sides by 4. And 80 divided by 4 is 20. And 60 divided by 4 is 15. And so these are sales, right? Because we didn't use S for sales. So if he made between $100 and $120, he made between 15 and 20 sales. So this is an OR inequality. And OR inequalities, right, you have to do them individually. So X is less than or equal to -2, or X is greater than 3. So X is less than or equal to -2, close circle this way, make sure it's clearly closed, greater than 3, open circle this way. All right, absolute value inequality have two solutions. What are the two solutions here? All right, X could be greater than 4, 1, 2, 3, 4. So all the numbers over here, or it could be X is less than -4. You have to flip the symbol for the negative solution, right? Numbers less than -4, like -7, make that true. And you have to show that. So here's -4, also open circle, and you have to write the word or. This one was an or inequality. They're not all or. If it was a less than symbol, it'd be and. Okay. Now, when you solve an inequality like this, you have to isolate the absolute value. You have to get that part by itself before you do it twice. Usually something that separates A's from B's on the test. So you have to do that part first. Then you do it twice. Once for +14, and then you flip the symbol for the negative solution. So you divide both sides by 2. And X is less than or equal to 7, or no, this is an and inequality because it's in between, it's less than here, and X is greater than equal to -7. It's in between -7 and 7 inclusive. All right, X is greater than -6. Now some people will quickly start doing this, but this isn't a negative solution, it's a positive solution, right? This is supposed to be a negative solution over here. So what's going on here? Well, this side's always positive, so this is all real numbers, right? There's no real number that you can put in there that will make that true. All right, so we're going to write a linear equality for this graph you see on the test. All right, we are going to do this. We're going to work backwards. So there's a 0, 5 for the y-intercept. All right, and then the slope, what's the slope of this? It's looking like a +2. All right, now remembering this is a dashed line and we've shaded below it, so it's y is less than 2x plus 5. That's that linear inequality. Is 2/8 a solution? So 2/8, let me get this out of the way, is right there. So it's looking like yes. All right, but you want to be sure you put these numbers, this x and y, into the inequality. Y is 8. 8. And 2 times 2 is 4, plus 5 is 9. Is 8 less than 9? Yes, it's a solution. All right, so we're going to plot a system here. And the system is, first one is y is greater than -3x. So the slope, right, is -3. And the y-intercept is 0, 0. Slope of -3 down 3 over 1. Like that. And it's dashed because it's greater than, not equal to. arrows on the ends, and we're going to be shading up here above the line. For the other one, the slope is 1, y-intercept 0, -7. 0, -7, slope of 1. Let me get all these out of the way. And we're going to be shading below. It's going to be solid because there's an or equal to. All right. And so we're above the red one, below the blue one. And let's use a different color. And so the shaded area is in here. And realize we're stopping at 10 and -10, but this actually goes on forever. Student council wants to sell more than $400, so that's greater than $400. All right. Worth of tickets to the dance. Tickets at the door are $4, so it's $4 for tickets at the door. That's the rate for tickets at the door. Tickets in advance are $2, $2 for tickets in advance. If the we're giving a discount for tickets bought earlier. If the dance hall has a capacity of no more than 150, so then the other one is door tickets plus advance tickets cannot be more than 150. It can equal 150, right? No more than is less than or equal to. So we're going to write and graph both of those. Right, so for the red one, we're going to find the intercepts, right? When d equals 0, we get 4 times 0 plus 2 times a equals 400. Divide both sides by 2. A equals 200. So advanced, that's at the bottom here, is 200. We can sell 200 tickets in advance. If A equals 0, let's see how many door tickets we can sell. And divide by 4. D equals 100. So door tickets, we only can sell 100. Okay, so we're going to connect those two. And it's greater than that. All right, but we're going to double check. One of the oh, it's greater, so it's dashed. Right now is 0, 0 a solution to that. 4 times 0 plus 2 times 0 is 0 greater than 400. And that would be no. So that means we're shading above, and that makes sense here, right? We wanted to sell more than $400. Then we have to do the other one. The other one, if D equals 0, we sell 150 in advance. Let me get rid of this. And if we sell 0 of the advance, we can sell 150 at the door. And this one will be solid. And now this, right, 0, 0 is a solution. So we're shading below. So we're shading above the red and below the blue. And so I don't make a mess here. I'm going to just show you the solution is in this area right here. That's where, so anything in that area will be sell more than $400. We'll make more than $400. It'll be above the red, but we will not exceed the capacity of the hall. And there you can see it all. Okay, so you could go graph this whole thing, and that would take you a long time, or you can just put this, right, this x and y into it. We need 2 yeses to be a yes. So 3, x is -2, minus 4 times y is less than 24. 3 times -2 is -6, minus 28, less than 24. That's -34, less than 24. So that's a yes. So we have to go check the other one. We need 2 yeses. So now we're going to put 2 times -2 plus 7 greater than or equals 2, -4 plus 7 greater than or equals 2, 3 greater than or equals 2, yes. So we got 2 yeses. This is a yes. It's a solution to the system of linear inequalities. It's in the overlapping shaded area. The distance between 2 numbers on a number line is greater than 12. Okay, so the distance on a number line is the absolute value of their difference. So one of the numbers is 5, and we don't know the other one. It's the absolute value of their difference. So that's the inequality we need to solve. Now remembering, these have two solutions. So you do it once for x minus 5 greater than 12, once for x minus 5 less than negative 12. You add 5 to both sides. Right? One of those numbers has to be greater than 17, or the other one has to be less than negative 7. Right? Now you could figure this out without the inequality, yes, just through logic. But it's an example of what is meant by an absolute value inequality. So we're going to sketch this linear inequality. Notice I have given you no grid, so let's just practice that. So we're going to make an x and y axis. There's our y axis. We're going to label it. There's our x axis. We're going to label it. We are going to use our y-intercept of 0, negative 5. 1, 2, 3, 4, 0, negative 5. Our slope of negative 2, which means down 2 over 1, down 2 over another 1. So it looks like that. This is going to be a dashed line. Right? And since it's in slope-intercept form, we can just shade. Right? We're going to shade above the line because it's greater than negative 2x minus 5. Good luck on the test.